Hello friends. 200 years ago, the Ordnance Survey set out to map Britain and Ireland for the first time. They started with a carefully measured baseline, and from that one precise measurement, using nothing other than angles and triangles, they measured the entire landmass. Today, we're going to do something similar. I'm going to take a baseline off modern maps, then using nothing but measurements of distant mountains, I'm going to see if I can triangulate my position. I'm Rowan McLaughlin, and this is the Cosmic Viking, the channel where we do this kind of stuff. So I'm going to be using Slieve Croob, one of my favourite mountains. We're going to measure the angular distance between that and Divis. Then we're going to go to Slieve Croob and measure the angular distance between this place, which we'll be able to see because it has this enormous water tower on it, and Divis, and then we'll be able to work out where we are, and I'm going to show you how. So first off, let's measure the angular distance between Slieve Croob. I can get in on the trig point there, up at the top. Oh yeah, I can see it. I can see it. I'll show you. So here the azimuth is reading, it's just under 120 degrees. And we'll turn towards Divis. Or rather, Black Mountain. I'm using the transmitter mast on the top of Black Mountain as our foresight. And now we're reading 220.5 degrees. So I'm using the modern transmission mast at the top of Black Mountain. And it's amazing to me to think that 200 years ago, when the men of the Royal Engineers were doing this work for the first time, they would have often used the prominent prehistoric cairns that are on the top of mountains because they would have been visible with their theodolites over really quite great distances. It's incredible to think that human effort some maybe 5,000 years ago or even more contributed in some way to this idea of being able to map the landscape. And it's a very fundamental human thing, isn't it? Just wanting to erect some sort of datum point, some sort of reference that we can always refer back to and try to understand our world in that way. So I'll dismantle this equipment. The sun has set and we're losing the light. And I'll see you on Slieve Croob at sunrise.
Although the forecast was for clear skies the next morning, as the sun set, clouds were already bubbling up over the summit of Slieve Croob. When I arrived there at dawn, I was reminded that prominent places are also the most likely places to obscure themselves.
And true to form in this channel, we've encountered the problem of mist. This would have been infinitely easier if I'd just come up here at a time when it was clear and we'd be able to make the observation without any problems. The problem is, I'm a hopeless romantic. I don't think it's going to clear. I am reminded though of the fact that the Royal Engineers often camped on summits like this, sometimes for months, waiting for the weather conditions they needed to make long distance observations. That must have been quite a life. Of course, these days we've got real-time maps, which is just bonkers, and we're sort of around here somewhere, and there's this wee wisp of cloud.
That wee wisp of cloud wasn't going anywhere, so I decided to return another day. What seemed like the next chance turned out to be very misty and windy, not good conditions for surveying. Finally, a promising day dawned, and I arrived at the summit once again.
Okay, third time lucky. It's time to make these observations. What a beautiful sunrise it is this morning on Slieve Croob.
Seeing conditions were really not ideal, but I did hope they would improve.
We're still waiting.
The haze lingered, and I couldn't see distant targets, so I decided to record footage that I could later contrast stretch and call out the azimuth angles as I went. And whilst far from ideal, this will hopefully give us some data to test the principle.
98, 97, 96, 95, 94, 93, 92, 91. So hopefully it's in there somewhere. Okay, now for Black Mountain, and it is, can I see it? Oh, it's very misty over in Belfast too. I'm sure if those men of the Ordnance Survey could see me, they would turn in their graves. This is not a precise way of working whatsoever. But I think we read 65 degrees. So let's do the calculations and propagate a little error margin and see how close we get. Okay, let's begin by writing down what we know. We've got our triangle, our baseline, and our two observations to the survey location. Let's call this side of the triangle A, that side B, that side C. This angle alpha, beta, and gamma. So we know various things. We know beta, which is the difference in those two azimuth readings that I read out. That's 100.5 degrees. Gamma is 30 degrees. And alpha, because the internal angles of a triangle must add up to 180 degrees, is 180 minus all those, which is 49.5 degrees. And we also know the offset of the baseline to the grid, because that's the baseline we've defined, and that's 4.56 degrees in there. And that will become very useful later on. So to work out the lengths of the sides of the triangle, we can use the rule of sines, which is A over sine alpha is equal to B over sine.
So the key point here is that we know B, the baseline. So with these angles, we can now work out the other lengths of sides of the triangle.
Of course, when the Ordnance Survey was first being done, they didn't have calculators, but they would have had computers, as in rooms full of people whose jobs it was to calculate numbers, and the tables they calculated would have been used for this sort of trigonometry. So anyway, cross multiplying this gives us an answer of A.
So we've worked out A, the distance between Slieve Croob and the water tower, 23.14 kilometres, and C, the distance between the water tower and Black Mountain, 15.22 kilometres. And we also work out an offset, the difference in grid eastings and northings, X and Y, which will allow us to plot the point that we've attempted to survey.
So let's put those offsets into the computer and see how close we got. I hope it's fairly close. Otherwise, this whole exercise will have been a disaster. Okay, I had to take a call there, but I worked out the coordinates and I've put them on the computer. So here is our baseline, and here is where our survey position, that water tower, actually is, and here the white dot is the coordinates I've calculated, and it's pretty close. I'm actually very, very pleased with this. I mean, it's not perfect, but it's close enough for rural work. Let's see how far we are off. We are 616 meters off, so not great. And as I say, those surveyors from the Ordnance Survey 200 years ago were able to do infinitely better than this, although they did use much more precise equipment and much superior methods to mine. As I say, they're likely turning in their graves. But this has got me thinking. I mean, we could get some better survey equipment and just see how accurately we can recreate this sort of survey process. I thought this was a really interesting exercise, hanging around at the top of mountains waiting for the conditions to improve, and I hope you thought it was interesting too. Thank you for watching, and I'll see you again.